Hello everyone, this is Pankaj and I welcome you all to new day, new question series. So once again, I have brought one more question for you. Let's see what we have in this question. So as we can see on our screen, we have one question. A galvanometer G of resistance to ohm is connected in the given circuit. The ratio of charge stored in the C1 and C2 we want to find. This is our C1, this is our C2. This is our galvanometer. Resistor 4 ohm and 6 ohm are also in the circuit. We have 6 volt of battery. So we want to find like how much charge is stored in C1 and C2, and we want to find the ratio of the charges in the C1 and the C2. So the diagram I have redrawn again, once again, like you can see here. The reason I have drawn the diagram once again so that I can explain which concepts we are going to use here. Okay, so here you can see that we have 6 volt battery. So at this point also we will have the 6 volt, and at this point we will be having basically our 0 volt. Now the first key concept which I am going to use here is I will assume that capacitors are at the steady state. So first key concept, capacitors are at steady state. It means they are fully charged and they will not allow any current to pass through it. So if current is passing, this current will pass through first 4 ohm. After this it will pass through the galvanometer. I am drawing the path of this current like this, and then the current will pass through the 6 ohm, and in this way it will complete its path. Okay, it will go in this way. Current will not pass basically through the 6 microfarad capacitor or 4 microfarad capacitor because it is fully charged. Okay, now in order to find the charges stored in the capacitor, I will need one more key concept, and that key concept is Q is equals to C into delta V. Delta V is basically potential difference across the capacitor. So this potential difference, suppose if I am saying this point as a, this point as a B, this point I am naming as a X, and this point I am naming as a Y. So I will need the potential difference between A and Y, as well as I will need the potential difference between X and the B. So I have the value of potential at A and B, but I will need the potential at the X and Y. So let's first find that value. So for that I will need the value of current. Okay, let me erase this part which extra, which is of no use to us. Okay, let's try. So first thing which I said, I will find the current by using the Ohm's law. V is equals to I into R. So as I have already told you, like path of the current, like from this point your current will start and it will end at this point. So potential difference we have 6 minus 0, that is basically 6. Value of current we want to find. Total resistance along this path is 4 plus galvanometer 2 plus 6, that will be again 12. Resistance value is 12. So value of I will be 6 by 12, which is nothing but the 1 by 2 ampere. Now we got the value of current. Next task is to find the potentials. Okay, so value of current we got here, which is basically equals to 1 by 2 ampere. Now next thing is find the potential difference. So first I will find potential difference at point X. So current is passing from A to X, it means A will be at the higher potential, X will be at the lower potential. So again V is equals to I into R. So it will be basically potential at A minus potential at X, value of current into value of resistance along this path. So potential at A is basically 6, potential at X we don't know, value of current is 1 by 2, and value of resistance how much we have, 4. So it will be basically 2 2s are, so our value of Vx will be 6 minus 2, which is equals to Vx. So potential at x will be basically our 4 volt. Now we got the potential at point x. Now next task, in the same fashion we will find the potential at point y also. For this I will consider this path. Potential of B I know, but potential of y I don't know. Current is passing from y to B. It means y will be at the higher potential and B will be at the lower potential. Again formula will be same. V is equals to I into R. This time it will be Vy minus Vb I into R. Value of Vy we don't know, value of Vb is 0, current is again 1 by 2, resistance is basically 6. So it will be 2 3s are. So this time we got the value of Vy as a 3 volt. Now we have the values. Now we can easily find the charges stored in the capacitor. So one by one we will find the charges stored in the capacitor. So first I will find Q1. Q1 is basically charge stored in the capacitor C1 and delta V, that is the potential difference. So value of C1, as we can see here along this path, potential difference will be 6 minus value of potential at Y, we got basically 3 volt. Value of potential at X basically we got as a 4 volt. Okay, now so let's try to find the value. C1 value how much we have? It is basically 4. Delta V, that is potential difference across the 4 microfarad, that is C1 is 6 minus 3. So value of Q1 will be equals to 6 minus 3, 4 into 3 will be 12 microcoulomb. So we got the value of Q1. Similarly, I will find the value of Q2, which is C2 into delta V. Value of C2 how much we have, which is 6. Potential difference if we try to find, it will be basically X and B, which is 4 minus 0. So 4 minus 0 we got, which will be Q2 6 into 4, which is 24 microcoulomb. So we got the value of Q1 and we got the value of Q2. Last we will find the ratio of Q1 by Q2, which will be 12 by 24, which will be 1 by 2. So our final answer is basically 1 by 2. Let's check the options. So options we have option number 4. Okay, thank you.